Welcome. Today we're going to learn how to use unit rates and new rates using equivalent ratios where we have fractions inside the ratios. So first, as a quick review, we're going to be using reciprocals. The reciprocal is when we take the numerator and denominator and we swap them. So the reciprocal of 3 over 4 will be 4 over 3. If we have an integer or a whole number, the reciprocal of that is going to be 1 over that original number. So the reciprocal of 9, or 9 over 1, will be 1 over 9. Now, we can use reciprocals to help us simplify some of these more complicated situations. So we have 2/5 over, or divided by, 3/4. Now, we can simplify this by multiplying both the top fraction and the bottom fraction by the reciprocal of 3/4. So if we do this, we can multiply by 4 over 3 to the denominator and by 4 over 3 to the numerator. This is something we can do instead of dividing by a fraction. So rather than dividing by 3 over 4, because it's difficult to do the calculations when you divide fractions, we can multiply by the reciprocal. So if we do this, the 3's will cancel out to be 1's, the 4's will cancel out to be 1's in the denominator, so we are left with just 1 in the denominator. In the numerator, we can go ahead and multiply going across the fraction, so 2 times 4 is 8, 5 times 3 is 15, so we'll end up with 8 over 15 divided by 1, which is just the same thing as 8 over 15. In this example over here, we have 18 over 3 all over 9. So I'm going to go ahead and rewrite this as 9 over 1 just so that it can be a little easier to see as a fraction. So I'm going to, instead of dividing both of these by 9, I'm going to multiply these by the reciprocal, 1 over 9. So when I do this, 9 and 9 will cancel out to be 1 and 1. So our denominator will just be 1. In the numerator, we can simplify a little. 18 and 9, you can divide each of those by 9, so we'll end up with 2 and 1. So now when we multiply across, we have 2 times 1 is 2, over 3 times 1 is 3. So we have 2/3 over 1. That's the same thing as just 2/3. So we are going to end up creating rates that look like the fractions that we started with, where it's a fraction over a fraction, or a fraction over a number. And then we can go ahead and calculate the unit rates, where we get the denominator to be 1, and use that to help us find the answer to each of these questions. So let's look at this first problem here. We're told Sergio is training for a triathlon. He can cycle 7 miles in a quarter of an hour. So first up, we need to figure out what his cycling speed is in miles per hour. Once we know what that is, then we can figure out if he can achieve his target speed of 25 miles per hour. So first, let's figure out what his speed is in miles per hour. So this means we need it in miles over hours. Since it's per hour, this is per 1 hour. So since we know we want to have that information, we're going to use the information that we're given for our starting rate. So we are told, to begin with, that he can cycle 7 miles in a quarter of an hour. So that means we'll have our miles on top, our hours on the bottom. So we'll have 7 miles over a quarter, or 1/4 of an hour. Now we need to somehow find how many miles he can travel in 1 hour. So this is going to be the unit rate. So we need to change this denominator from 1/4 into 1. Well, we can easily do that by multiplying by the reciprocal. So the reciprocal of 1 over 4 will be 4 over 1. And whatever we do to the denominator, we need to do the same thing to the numerator. So we will also multiply the numerator by 4 over 1. When we do this, sure enough, 4 and 4 will cancel, so we're left just with 1 in the denominator. In the numerator, 7 times 4 divided by 1 will give us 28. So this tells us, we can say, his cycling speed is 28 miles per hour. We can abbreviate miles per hour as mph. It's a very common abbreviation. So, if we look at this, we can see that, yes, he did achieve his target speed because his target speed was to go 25 miles per hour, and he has exceeded that. So we can say he passed his target speed by 3 miles per hour. So he's going 3 miles an hour faster than what his original goal was. So now that we know that, now we want to try to figure out how long will it take him to ride 84 miles. Well, we can use our unit rate that we have here to help us with that calculation. So we know he can travel 28 miles in 1 hour. So we can use this information to help us find the new rate or the new relationship that we want. So we want to know how long it will take him to ride 84 miles. Well, we know we have 28 miles here. We need to get to 84 miles over here. It turns out that 28 times 3 will get us 84. So we can multiply by 3 to the numerator and the denominator. And if you check in the calculator, 28 times 3, sure enough, that'll be 84. And in the denominator, 1 times 3 will give us 3. So if we're looking at this information, we can see that he can ride 84 miles in 3 hours. So we can say it will take him 3 hours to ride 84 miles. Now, this can also be useful if we are trying to figure out how far, in this case, for mowing a lawn. We want to know how much someone can mow in 1 hour and how long it'll take him to mow this entire lawn. So we're told Lucian mows this lawn every other weekend. He can mow 12,000 square feet in 2/3 of an hour. So we can set up our ratio. We have the square feet, or how much he covers, in however much amount of time it takes. So what we can do is we need to figure out how much he can mow in 1 hour. So we'll need to change this 2/3 into 1. Well, we can easily do that by multiplying by its reciprocal. So the reciprocal of 2/3 will be 3/2. And whatever we do to the denominator, we need to do the same thing to the numerator. So we'll multiply the numerator by 3/2 as well. Now, just to help keep things a little more consistent, I'm going to rewrite 12,000 as a fraction so that it's easier to line up the numerators and the denominators. So I'll just rewrite this over here. So we have 12,000 over 1 times 3/2. And in the denominator, we have 2/3 times 3/2. So now we can go ahead and cancel things out to simplify. 2 and 2 will cancel out. 3 and 3 will cancel out. So in the denominator, we're just left with 1 hour. In the numerator, we have 12,000 and 2. We can divide those both by 2, so we'll get 6,000 and 1. So now when we multiply across, we'll have 6,000 times 3. That'll give us 18,000 over 1 times 1, which is just 1. So we can tell that Lucian can mow 18,000 feet squared, or square feet, in 1 hour. So based on this information, if he is trying to mow a lawn that is 72,000 square feet, well, we can set up this relationship. Our unit rate is 18,000 square feet over 1 hour, and we need to somehow change this into 72,000 square feet over some amount of hours. We don't know exactly how many. Well, if we mess around on the calculator, it turns out 18,000 times 4 will give us 72,000. So we can multiply the numerator and the denominator each by 4, and we'll get that in it will take 4 hours to mow 72,000 square feet. Four hours, 72,000 square feet. Now on the back, we are now trying to compare Lucian with his cousin Daniel. So sometimes Daniel mows the lawn. He can mow the lawn, he can mow 15,000 square feet in 3/4 of an hour. So if we want to find his rate, how much he can mow in 1 hour, we can set this up as how much he mows, 15,000 square feet, over the amount of time it takes, 3/4 of an hour. And to figure out how much he mows in 1 hour, we can change the denominator to 1 by multiplying by its reciprocal. So we can multiply by 4/3, and we'll do the same to the numerator. So sure enough, everything will cancel out in the denominator. In the numerator, 15,003, you can divide those both by 3, so we'll end up getting 5,000 instead. So 5,000 times 4 will be 20,000 square feet. And in the denominator, we have 1 for the hours. So we can say Daniel mows 20,000 square feet in 1 hour. Up next, Arlene boarded an airplane in Richmond, Virginia, and flew, this is going to be 414 miles, directly to Charleston, South Carolina. The total flight was 3/4 of an hour. How fast did the airplane fly in miles per hour? Well, since it's miles per hour, that means it'll be miles over hours, and specifically over 1 hour. So we can set up our starting rate. We have the distance traveled, 414 miles, over the amount of time, which was 3/4 of an hour. We need to figure out how far it traveled in 1 hour. Well, again, we can multiply whatever the denominator is by its reciprocal. So the reciprocal will be 4/3. And we need to do the same thing to the numerator. So when we do this, everything in the denominator cancels out. In the numerator, it turns out when you multiply 414 and 3 are actually divisible. So 3 divided by 3 is 1. 414 divided by 3 will be 138. And if you multiply 138 times 4, you'll end up getting 552. So this tells us that the plane flew 552 miles each hour. So if we wanted to know how far the plane will fly after 4 hours, we can take this unit rate of 552 miles per hour, and we need to get a new rate where we have 4 in the denominator for the number of hours. Well, to scale this up, we can multiply the denominator and the numerator each by 4, and once you type that into the calculator, you'll find that it works out to be 2,208 miles. So we can say after 4 hours, the plane travels So we can say after 4 hours, the plane travels 2,208 miles. Let's look at this next question. It says, Joel is baking shortbread for a bake sale. The recipe calls for 1 1/4 cups of flour and 1/2 stick of butter. How many cups of flour will Joel need for 1 stick of butter? So this is telling us we're going to need to eventually have 1 stick of butter in our denominator. So if we set this in the denominator, then we'll be able to find a unit rate to help us decide how many cups of flour we need for that. So we can use our starting information to build our starting rate. Now, 1 1/4 cups, it's awkward to work with this as a mixed number, so instead, let's convert this to an improper fraction. So 1 1/4, that'll be the same thing as 5/4. So we have 5/4 cups of flour and 1/2 stick of butter. So I'm going to put the flour amount on top and the butter amount on the bottom. So we can set up our starting rate of 5/4 for the amount of flour over 1/2 stick of butter. And we eventually need to turn this into 1 stick of butter. Well, to change 1/2 into 1, we can multiply by 2, or by 2 over 1. And whatever we do to the denominator, we also need to do the same thing to the numerator. So we'll multiply the numerator also by 2 over 1. And when we do this, we can go ahead and cancel out the 2's in the denominator. And in the numerator, 5 times 2 is 10, over 4 times 1 is 4, so we have 10/4 over 1. We can simplify this down. 10 and 4 are both even numbers, so we can divide those by 2. So this will be the same thing as 5 over 2 over 1. So this is 5 over 2 cups of flour over 1 stick of butter. So we can say Joel needs 5.5 cups of flour. Now, if Joel has more butter, let's say Joel has 3 sticks of butter, we can take this information and scale it up to help us calculate how many cups of flour he'll need to use all of that butter. We can take our unit rate, where we have 5 over 2 cups of flour for each 1 stick of butter, and we need to scale this up so that we end up with 3 sticks of butter. Well, to change 1 into 3, we can do that by multiplying by 3. So if I multiply the denominator by 3, I also need to multiply the numerator by 3. So 1 times 3 is 3. That checks out. In the numerator, 5 over 2 times 3, we can put this as 3 over 1 to just help us line up the numerators and the denominators. 5 times 3 is 15, and 2 times 1 is 2. So we end up with 15 over 2 for the cups of flour. So we can say that Joel needs, instead of 15 over 2, that's going to be the same thing as 7.5 cups of flour. Now, in baking or any sort of cooking, it's very common that you might need to adjust the recipe, either by scaling it up or scaling it down, depending on how many people you want to feed, or sometimes you're limited by how much of a certain item you have. If you, only have 1 stick of butter, you can't scale the recipe up to 3 sticks of butter. You'd have to keep it to just the 1 stick. And likewise, if you only have 1/4 of a stick of butter, you could try to scale this down so that you can use up all that butter that you have remaining in your fridge. Another common instance where we use scales, either scaling up or scaling down, is when it comes to maps. So maps are representations of really large distances on a smaller space. So this map here, we can see it's 3/4 of an inch from the house to the swimming pool on this map. And this house to the school, this is going to be 2 inches apart. In the real world, they're going to be much farther apart than 3/4 of an inch and 2 inches. So for this map, we are going to try to use this information that's printed with information that exists in the real world. So for this problem, Ava knows the swimming pool is 1/3 of a mile away from her house. So if we're looking here, the swimming pool to house, that's going to be this distance here. So we can see that on the map, it's 3/4 of an inch, but in the real world, it's 1/3 of a mile. So we need to figure out what the actual distance is, or what is the actual distance in miles that's represented by 1 inch on the map. So since we want to figure out miles for each 1 inch, then that means we'll want to set it up where we have the miles on top and the inches on the bottom. So for this problem, the actual real-life miles between the house and the swimming pool is 1/3. And this is matched with, or corresponding to, the distance on the map, which is 3/4 of an inch. Now we somehow need to change this, so this rate, so that we have 1 inch in the denominator, and whatever the miles is that goes with it, that will be our answer. Well, to change 3/4 into 1, we can do that by multiplying by its reciprocal, which is 4/3. So whatever we do to the denominator, we also need to do to the numerator. And now we can go ahead and cancel out a lot of these numbers. In the numerator, we can't cancel anything out, but we can multiply across. So 1 times 4 is 4 over 3 times 3, which is 9. So we end up with 4/9 of a mile for each 1 inch. So we can say 1 inch represents 4/9 of a mile. So based on this information, we can now figure out how far the school is from her house in the real world. So we can take this unit rate of 4/9 of a mile for each 1 inch, and we need to turn this into the new rate where we're using the distance on the map from the house to the school. So we can see that the house to the school is 2 inches apart, so we need to scale this rate up so that it has 2 inches for the denominator. Well, to scale this up, we can multiply 1 times 2 to end up getting 2. And we can do the same for the numerator. So when we do this, 1 times 2 is 2, good. In the numerator, 4/9 times 2, this will be 4 times 2, which is 8, all over 9 times 1, which is 9. So we end up with 8/9 of a mile over 2 inches. Or we can say the school is 8/9 of a mile away from the house.